What we're going to be talking about tonight is modeling with the exponential functions, which we've actually already been doing. That's what your project has mostly been about for this unit. And so you have done modeling before. Modeling is not something that is new. We know that a model is an equation. It's just an equation that represents something in the real world, something that we can use to make a prediction. But it is, in fact, an equation. So anytime you're asked to find a model, they're asking you to find the equation. And up to this point, we know that regression is our easiest way to find a model for a set of data. And our biggest tool for doing that is our calculator, and that's where we go to stat edit and stat calculate. Now, we've also learned with this project, you can use a spreadsheet. There was a video earlier about how to use a spreadsheet to help you find those regressions and the R-squared value. And we remember from all our other problems, the R-squared value is what tells you whether one is better than another one. The closer to 1, the better the value. Specifically, this time, what we're going to be talking about, if you go to Stat and Calculate, this year we've done linear, we've done quadratic, we've done cubic and quartic, and now we're going to get down here to some of the ones at the bottom. This unit we've done logarithmic, ln, if you recall, is the natural log, exponential, exp is for the exponential model, and then PWR is the power model. And so these are going to be the ones that we're going to be talking about today. We know the process. Stat edit, and you enter in your points. X is in one column, Y is in another. If they give you 2 points, just enter in the 2 points. If they give you a table of points, put in the whole table of points. But stat edit is where you do that. Stat calculate is then where you choose the model that you want to do. Specifically, the two models that we're really going to be talking about today are the exponential and the power. The exponential model is, on your calculator, they do a times b to the x power. If you remember our exponential model, we did c times a to the x, but they always use the letters a and b. So b is your base. It's the number that has the exponent, and a is the coefficient in front of it. The power function is a times x to the b power. So x is not the exponent. There is a number up here. But unlike the ones we've done before, quadratic, this was just 2. Cubic, this was just 3. For the power function, b can be decimals and positives and negatives and fractions and all kinds of things. And so they do treat that as a separate model. And so all you're looking for when you go into the calculator is what is a equal to and what is b equal to. And we know that once we have a model, we then can use it to do predictions. So if we look at an example like problem 18, now number 18 here is asking me to find an exponential function of this form that goes through these points. So what I need to do with my calculator is I need to go to stat edit. I'm going to put in my x values, which are 2 and 3. 2, enter, 3, enter. And then I'm going to put in my y values, which are 18 and 108. And so I've entered in my points. I double check my points, and they're good. So now I'm going to go to stat and calculate, and I'm going to choose the exponential model, which is 0. So exponential regression, I get 0.5 times 6 to the x power. So y is equal to 0.5 times 6 to the x power. That's going to be my exponential model. Now notice my r-squared value didn't show up. If you have forgotten, if you go to catalog and the D's, diagnostic on is what you're looking for. If you turn your diagnostic on, now when I go to stat and calculate and 0, exponential, my r-squared value will show up. And this was an r-squared value of 1. So that means it goes exactly through those 2 points. But that is what we are dealing with today and how we find models for sets of data.